The human mind is a powerful instrument, capable of conjuring vivid and detailed experiences. We close our eyes and effortlessly transport ourselves to different times and places. But this incredible capacity for imagination presents a challenge. How do we distinguish between real memories and those we've merely imagined? This is the crux of reality monitoring, a fundamental cognitive process that helps us navigate the world with accuracy. Our ability to differentiate between real and imagined experiences is more complex than it seems. It's not simply a matter of labeling memories as real or fake. The line between the two can be surprisingly blurry. This blurring arises because our brains utilize similar neural machinery for both perception and imagination. When we perceive the world around us, our sensory organs send signals to our brains. These signals are processed and interpreted, forming the basis of our perception. Imagination, on the other hand, originates within the brain itself. However, the brain regions involved in processing sensory information are also active during acts of imagination. This overlap in neural activity makes it challenging for our brains to always distinguish between what has actually happened and what we have merely thought about. A vivid daydream, a compelling story, or a strong suggestion can all lead to the creation of memories that feel incredibly real, even if they never actually occurred. To understand the complexities of reality monitoring, we must delve into how the brain processes real and imagined information. Real-world experiences are grounded in sensory perception. When we see, hear, touch, taste, or smell something, our sensory organs transmit detailed information to the brain. This sensory data forms the foundation of our perception of reality. Imagination, in contrast, originates from within the brain itself. It is not directly driven by external stimuli. When we imagine something, we draw upon our existing knowledge, memories, and experiences to construct a mental representation. Despite these differences in origin, both perception and imagination engage overlapping brain regions. The visual cortex, for example, is active not only when we see actual images, but also when we visualize something in our mind's eye. Similarly, auditory areas become activated when we imagine a familiar tune. However, there are subtle but important distinctions in brain activity during these processes. Imagination tends to involve greater activity in the frontal cortex, particularly the prefrontal cortex, which is responsible for higher-level cognitive functions, such as planning, decision-making, and working memory. This heightened frontal activity during imagination is thought to reflect the greater cognitive control required to manipulate and maintain internally generated information. Within the intricate network of the brain, a specific region plays a crucial role in our ability to distinguish between real and imagined experiences, the anterior medial prefrontal cortex, or AMPFC. Situated at the front of the brain, the AMPFC is a hub for a variety of cognitive functions, including attention, decision-making, and different forms of memory. Its role in reality monitoring makes it essential for navigating the world accurately and forming reliable memories. The AMPFC acts as a vigilant gatekeeper, evaluating incoming information and making judgments about its source. It receives input from various sensory processing areas, as well as from regions involved in memory retrieval and emotional processing. This convergence of information allows the AMPFC to compare and contrast different types of input, helping to determine whether an experience originated from the external world or from within our own minds. When the AMPFC detects a strong match between sensory information and an activated memory, it strengthens the perception of that memory as real. Conversely, when there is a mismatch or a lack of sensory detail associated with a memory, the AMPFC may flag it as potentially imagined. This process of cross-checking and evaluating information is ongoing and dynamic, allowing us to constantly update our understanding of reality based on new experiences and insights.